Okay, if you are new to this channel, please kindly subscribe, like and share. Today, I'm going to teach us calculus. And I'm going to start with introduction to calculus. Introduction to calculus, how do we differentiate in calculus and how do we integrate? Now, before we go into the complex questions, let's start from the simple one. Now, when we talk about calculus, we have first principle method, first principle, and we have general rules. Now, but for today, I will start with this general method, general rules of differentiating in calculus. Now, what is the formula when we are differentiating in calculus? Now, today, I'll be talking on differentiation. Actually, calculus is divided into three: the limits, the differentiations, and the integrations. But today, my aim is to teach on differentiation. How do we differentiate? This is a formula. Now, this is a formula for differentiations. And anytime we want to differentiate, how do we differentiate? We take this power, we use it to multiply this. That will be nx. We now subtract, we remove 1 from this power, minus 1. That means y equals to nx raised to power n minus 1. That is the way we differentiate. We multiply this power by this, and we have to subtract 1 from that power. That's how to differentiate. Now, after that, after we've known how to differentiate, now let's give some examples. If I am giving something like this, y equals to s squared, and they say find dy dx. Now, dy dx means I should differentiate this. If they don't use dy dx, they can also use find. They can say find y prime. They ask me to find y prime. It also means dy dx. You can also do it like this. Also means I should differentiate it. I should differentiate it. Now, let us proceed. Or they ask me to do like this. If they do like this, I think I've written down before. That means they ask me to differentiate it. Now, if they ask me to differentiate y equals to s squared, and firstly, what am I differentiating? This is what I'm differentiating, and we call it functions. What I'm differentiating is called functions. And how do we differentiate it? Y equals to, like I explained, we bring this power, is to multiply this. That is 2 times x, that is 2x. And we subtract 1 from this power, minus 1. That means y equals to 2x, 2 minus 1, 1. Y equals to 2x. So that means the y dx of s squared is 2x. Now let's take another one. I'm trying to start from the simple to complex. If they give me something like this, y equals to 1 all over x, and they ask me to find dy dx. They ask me to find dy dx. How will I do it? Y equals to, if I want to differentiate something like this, 1 all over x, so it is advisable for you to bring the x up. When you bring the x up, it will become x raised to power minus 1. Because in our law of indices, when you have 1 over a in our law of indices, when you want to bring it up, it becomes a raised to power minus 1. A raised to power minus 1. When you have 1 all over x a, if you want to bring it up, it becomes x raised to power minus 2. In fact, when you have x raised to power 3, x raised to power 3. Now, if I want to bring it down, it becomes something like this. So, like that, like that, like that. That's our law of indices. And for me to be able to differentiate this, I have to bring this one up. That's why it becomes x raised to power minus 1. So I cannot differentiate. I'll say y equals to this power. I'm going to use it to multiply this. Minus 1 times x raised to power minus 1. I will now subtract 1. The way I used to remove 1 from the power. Minus 1. So that means y equals to minus 1 times x, that's minus x. And minus 1 minus 1 minus 2. Minus 1 minus 1 minus 2. That means our answer will be y equals to. Now, if I want to take away this minus, like I showed us in the law of indices, like when you have x raised to power minus 2. If I want this minus to go negative in law, we call this negative law, negative index law, and indices. If I want to take this minus away, it becomes 1 all over s squared. So if I want to let this negative go, that will be minus 1 all over s squared. That is. Now let's look at another one. If I'm doing something like this, find if y equals to this, find f prime. First derivative. It also means dy dx. Also means dy dx. Like in calculus, or in further math generally, if we see something like this, f of x also means y. Because this one, you can write it like f of x. Now, if you have not watched my videos on functions, mapping and functions, you should try to do so. Now, f of x also means y. So they can put f of x here, we should know that they are talking about y. Okay? Now, if they give me something like this to differentiate, that means I have to change, I will say y equals to root of x also means x raised to power 1 all over 2. This means half, it means half. So that means in mathematics, if you have something like this, root 4 means this, which is also 2, because square root of 4 is 2. Now, can I differentiate? I can differentiate it now. That will be y equals to, do not forget, I'm using this power to multiply this. That means 1 over 2 times x, that's 1 over 2x. And 1 over 2, I will now remove 1 from it, minus 1. You can say 1 over 1. 1 over 1 is still 1. That will be 1, y equals to 1 all over 2x. I can find the LCM here. And what's my LCM? My LCM is 2. 2 in 2, 1. 1 times 1, 1. Minus 2 in 1, that is 2. 2 times 1, that is 2. That will be y equals to 1 all over 2x. 1 minus 2, that is minus 1 all over 2. So that will be y equals to 1 all over 2. I can bring this one down. X raised to power minus 1 over 2. I can decide to bring it down. And the minus will go. So minus has gone because I brought it down according to the law of indices. So that is the answer. Now the same thing, if they give us something like this, assuming they give us something like this, y equals to x raised to power 7 minus x raised to power 4 all over x raised to power 5. They find dy dx. How do we differentiate this? That means it will be y equals to, if you want to differentiate these kind of things, you have to put x raised to power 5 under this box. That will be x raised to power 7 all over x raised to power 5 minus x raised to power 4 all over x raised to power 5. In our normal mathematics, it is possible. Like if they give us a minus b all over b. So you are allowed to write A all over B minus B all over B. Why? Because it will still give you this thing back. Why? Let me show us. If you find the LCM, what is the LCM? B. B in B1, 1 times A. Minus B in B1, 1 times B. As you can see, it gives us this thing back. So you are allowed to write something like this. Now that I've written it like this, now law of indices, it will become x, y equals to x raised to the power 7 minus 5. Because in our law of indices, when we have something like this, a raised to the power 4 all over a raised to the power 3, they are the same base. We have the same base, the power are different. And if you have a divisional law, you just take one base and we subtract the power, a raised to the power 4 minus 3. That will be a raised to the power 1. That's our law of indices. So the same thing I did it, they are the same base. I have to subtract the power because they stand in the form of divisions. Minus x raised to the power, they are the same base, 4 minus 5. 4 minus 5. That will be y equals to x raised to the power 7 minus 5, 2. Minus x raised to the power 4 minus 5 minus 1. So we cannot differentiate it. We have not differentiated yet, we cannot differentiate it. We use the power to multiply. That is 2x, 2 minus 1. We subtract from the power. Minus. Because there is a minus f, you can put this one inside the bracket so that you will not do mistake. This minus 1, you use it to multiply this. Minus x, you subtract 1 from this minus 1. Minus 1 minus 1. That will be y equals to 2x, 2 minus 1, that is 1. But you don't need to write it. Anything raised to power 1 is still that thing. Minus, no, minus is minus plus. X raised to power what? Minus 2. Now, when you have something like this, you can just write a final answer by saying y equals to 2x plus, this one become, if you want this minus to go, just become 1 all over s squared. 1 all over s squared. That is, you have differentiated that. Now, if they ask us to find y ds, like they give us y equals to 3s squared plus 2 all over root x plus 6s cubed plus 4x plus 4x. They give us something like this, like different, find dy dx. They are giving up like this to differentiate. That means if you want to differentiate this, that will be y equals to, we use these 2 to multiply this 3x, that will be 6x. Do not forget you will subtract 1 from these 2 and it will be 1. So you don't need to write 1 here again. Plus, if you want to differentiate this, you can just say 2 all over root x is x raised to the power 1 over 2, like I told you earlier. Plus, you cannot bring it up. When you bring this one up, it will carry minus. So it will become x raised to the power minus 1 over 2. So plus 3, if you multiply 3 by 6, that's 18x. You subtract 1 from this, that is 2. Plus, anytime you have to differentiate 4x, anything, that will be 4. Don't forget, you have not differentiated this. We just change this one to half, we bring it up. I have not differentiated it. We have differentiated this. 3 times 6, that's 18x squared and 4. The differentiation of 4x is 4. Let me show you why the differentiation of 4x is 4. 4x, it carries the power of 1. If you use that 1 to multiply this, you subtract 1 here. That will be 1 times 4x, 4x. 1 minus 1 is 0. Anything raised to the power 0 is 1. And that means 4 times 1, that is 4. That's why I arrived at 4. That means that anytime you have to differentiate something like 4x is 4, differentiation of 5x is 5, differentiation of 6x is 6, and so on and so forth. But differentiation of a single number, they give like 6. Differentiation of 6, that is 0. Differentiation of 7 is 0. Differentiation of 1000 is 0. A single number, it will always be 0. That's the differentiation of single number is always 0. So that means y equals to 6x plus, now let us differentiate this because we have not differentiated this. Now put this inside the bracket. Bring minus 1 over 2 here, minus 1 over 2 multiply by 2x is minus 1 over 2. Don't forget you remove 1. Minus 1 all over 1. Plus we have differentiated this. 18x squared plus we have differentiated this plus 4. So it becomes y equals to 6x plus, plus times minus, minus. 1 times 2x, that is 2x all over 2. I can now find the LCM. What's the LCM of this? That is 2. Don't forget it is power. 2 into 1. 1 times minus 1. Minus 1. 2 in 1, 2. 2 times 1, 2. Plus 18x squared plus 4. So that becomes y equals to 6x minus, this guy can cancel this. Minus x